Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the question rotate image. The question says you are given an n cross n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. You have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. Okay, so we have to rotate the matrix. In the example one we can see by 90-degree clockwise. So after rotating it, this will convert to this, and we have to do this in place. So the very brute force approach is the in place algorithm. Here we can create a new matrix as a result matrix, and we can observe what changes are done here. So we can observe here from the original matrix, let's say 1. Let's first mark the indexes 0 1 2, and here also 0 1 2 0 1 2. So I'm talking about the brute force approach. So we can see the 1 is at 0 comma 0, and after uh, rotating it by 90-degree clockwise, we can see the 1 is at 0 comma 2. So 1 was initially at 0 comma 0, and now it is at 0 comma 2. And if you talk about any random element, let's say this, or let's say this element, so this was at 2 comma 1, and now it is at 8. Previously this was 1 and this is 8, so 8 is now at 1 comma 0. Sorry, this was 8 was 2 comma 1, and now it is at 1 comma 0. Yes, okay. And let's take one more example. Let's take this 3 was initially at 0 comma 2, and now the 3 is at 2 comma 2. So we can observe from this pattern that initially the element was at I comma j. I should write here, initially the element was at I comma j, and after rotating it by 90-degree clockwise, we can see the element is simply at j comma n minus I minus 1, n minus I minus 1th position. You can observe from the example also. So n was here 3, and is the size of the matrix. So this was I comma j, and this is I comma j comma n minus I minus 1. N was 3, 3 minus I, which is 0, minus 1, which is 2. Similarly here also, this is 0 comma 3 minus 0 minus 1 2. Similarly here also. So this is the brute force approach, that we create a resultant matrix, a new matrix. But the question is the question is given that we have to do this in place. It means we are not allowed to create any extra 2D matrix. So we have to do this in place. So we have to find another observation or pattern by which we can solve this. So let's analyze it. Now if I talk about the optimal approach says that we have to do this in place. Alright, so what we can observe to do this in place, we have to do something, we have to perform some operation into the original matrix only. So how can we observe it? We can see in the, let's see the example one only. We can see here this column. Alright, and in the resultant matrix, this row, can you see that this column is equal to the reverse of this row? This is 147 and this is 741. This row is just the reverse of this column. So what we can understand from here, we can see that every column here is just the reverse of the row here. The third column here is just the reverse of the third row here. So we can just rotate the matrix 90-degree by clockwise by just doing two operations. How can we achieve this? Converting the column to reverse of the row, we can transpose first. Okay, transpose. I am using mouse, so that's why I'm not able to write correctly. And then we can just reverse the row. Reverse. First of all, we will convert this column into row. This will be done by transposing the matrix. Next, we can reverse the row. Now, our column will be converted to reverse of the row by using just these two operations, and we will get our resultant matrix. So let's see how can we transpose our matrix. So transpose just says that converting column into the rows. So let's take an example here only. After converting this matrix, after transposing this matrix, okay, so what we will get, this will be 1, this will be 4, this will be 7, this will be 2, 5, 8, and this will be 3, 6, 9. We can see this is the transpose of this matrix and the diagonal elements are same. Now if I talk about the other elements, take this 4 and take this 4. This 4 here is gone to its diagonally opposite element. This 4 has gone here at the place of 2. See it. And this 2 has gone to its opposite diagonal element, that is here. So we can see we have to just swap the opposite diagonal elements. Okay, we have to just swap the opposite diagonal elements. 4 is swapped by 2, 7 is swapped by 3, and 8 is swapped by 6. Okay, so but we have to observe that we have to swap one half diagonal. We can choose one triangle and will perform swap to the opposite diagonal elements once. Okay, so we can simply say if I is less than j, we will swap it. Now what we can do in the second operation, reversing matrix, we can just use a STL function reverse. This will help us reversing the rows. So let's go to the implementation part. First I should erase this, then I will go to the implementation part. So let's erase it all. Now what I told you, first of all let's declare the size of the matrix, that is matrix dot size. Now what I said, that first transpose the matrix. Okay, I am here transposing the matrix. I am writing the two for loops. Now we have to just swap in one half, otherwise if we will swap in both the halves, then our matrix will be converted to original matrix. So we will swap in only one half triangle, one half. You can take the upper half or you can choose the lower half. So I am choosing the upper half where I is less than j, and we will swap the elements. Matrix of ij with matrix of ji. Now this transpose has been done. Transpose. Now we have to just reverse the rows. How can we reverse the rows? We can go to each row first of all. Let's say starting from row 0 to row last, and we can just call the STL function reverse, or we can just do this by using two pointer approach also, swapping taking I and j at starting and ending and just swapping and keep moving I and j. but we can use here STL also, so I'm using STL for simplicity. So matrix of row dot begin comma matrix of row dot end, and yes, it is completed now. Now we are sure that our matrix is rotated by 90 degrees clockwise. Let's run this and check if we are able to pass the sample test cases. Yes. Now let's submit it and check whether we are able to pass all the test cases or not. So yes, we are able to pass this all the test cases and we have solved this problem successfully. And now if I talk about the time and space complexity, so time complexity, we can see here is big O of n square, because we are running two for loops, and space complexity is big O of 1, because we are not using any extra space, big O of 1. Okay, so what we understood from this problem, that how can we rotate the matrix. So this question was just about rotating the matrix by 90 degrees in clockwise direction. Now if I tell you about what about rotating the matrix in anti-clockwise direction, nothing. We just have to, you can say, observe the pattern. Every rotating matrix can be done by, most of the questions, like they can be done by the similar pattern. For example, if we are asked to rotate the matrix by 90 degree anti-clockwise, what we will do, we will just, in the step 1 we will transpose, the step 1 will be same, and in the step 2, here we are reversing the rows, and if we have to uh, rotate 90 degrees anti-clockwise, there we will rotate by column. You can do the dry run also on your own, and similarly using the same pattern of rotating the matrix, we can rotate the matrix anyhow by 180 degree or 270 degree. We can rotate the matrix. Okay, so I hope you understood. So this was all for this problem. Till then, keep learning and keep upgrading yourself. Thanks for watching. See you in the next video.